All right, welcome, ladies and gentlemen, to our lesson 4 from our study of rational functions. We're going to be looking today at the rational expressions, specifically looking at how to simplify, multiply, and divide rational expressions. All right, so let's see first what it means to be in simplest form. Since a rational function or a rational expression is just a fraction, it means it's going to be in the simplest fraction form, and that just means when there are no common factors in the numerator and in the denominator. Now, we have done this obviously many times before when our study of just basic fractions, and it really just looks like if I have the fraction 6 over 8, oops, that's supposed to be an 8. When I do 6 over 8, 6 is really 2 times 3, and 8 is really 2 times 4. And since they have a common factor of 2, I can cancel those two things out, and I'm left with 3 over 4. Now, normally we think about this as dividing by 2 and dividing by 2, but it's the same idea, canceling out the common factor of a 2. So when we look at today's stuff, we're going to be looking at the same kind of idea. We're going to be doing a bunch of that type of problem. So when we are doing these as rational expressions, since we have x values in the denominator, or variables in the denominator, we have to make sure that the reader understands there are x values that are not allowed in the final answer. You can think about those as the holes that we did from graphing. But we need to make note of any points that make the denominators equal to 0. And it's any denominator throughout the entire question. And you'll see what I mean by that in a few minutes. So here are the how-tos. This is the list, the kind of the order in which we're going to do things. We're going to factor the numerator and the denominator. We're going to cancel out any common factors from both. And we're going to state the domain restrictions as part of our final answer. So let's get right into a few examples. So this is our first one. We're going to simplify this. And as the notation said earlier, we need to factor the numerator and the denominator. Well, I know that two numbers whose product is 25 and whose sum is 10 is 5 and 5. So I'm going to say this is x plus 5 times x plus 5. And likewise in the denominator, 20 is 4 times 5, and 9 is 4 plus 5. So that means I have x plus 4 and x plus 5. So right in here, I'm going to make a note that says x cannot be, well, it can't be negative 4 because it makes the left one 0. And it can't be negative 5 because it makes the other one 0. Now I look at the top and the bottom. So I've factored the numerator and I've factored the denominator. I'm going to cancel anything that is common. They factor to ones. And I'm going to write my final answer as the leftover piece. So the leftover pieces are x plus 5 over x plus 4. This statement where x cannot be negative 4 and negative 5 is part of your final answer. And there we go, we have our answer to this first problem. So one of the key pieces that you really need to know how to do is how to factor, essentially factor quadratics for the most part. Some problems might end up being cubics, but not very often. All right, so let's look at a separate example here, or another example. We have an example that says negative 27 x cubed y. Now this one has no plus signs or nothing like that. So we're going to think about this in a little bit different fashion. I want to think about this just like I thought about the problem where I had 6 over 8, since 6 over 8 could be written as something else. So I know that 27 can be written as 9 times 3. I know that x cubed can technically be written as x times x times x. And y to the first power is just y. Now, this is not what you have to do every single time, but I want to show why this is going to happen the way it's going to happen. So here I have 9. I have x to the 4th, which means x times x times x times x. And I have a single y in the denominator as well. So I'm going to cancel now, because technically I've factored. I'm going to cancel anything in common. So I'm going to cancel that 9 and that 9. They both become 1s. I'm going to cancel that x and that x. They both become 1s. I'm going to cancel all the x's that they have in common. And I'm going to cancel the y that they have in common as well. And I'm going to make my answer statement. Here I still have a negative. 1 times 3 times a whole bunch of 1s. So it's a negative 3 in the numerator. And then denominator, I have a whole bunch of 1s and a leftover x. But we have to make the statement again from the original problem. Any one of these x's cannot be 0. And also this y value cannot be 0 because it makes the y piece equal to 0. So we have two different statements here. We have x that can't be 0, and we have y that cannot be 0 because it makes the denominator equal to 0. And there we have our final answer for this particular problem. What I wanted to point out, though, is there is a faster way to do this particular problem, is if I think about 27 and 9, I know that I can cancel a 9 out of there and a 9 out of there. In the top, or in the numerator, I have 3 x's, x to the 3rd power. I can cancel all 3 of the x's because I have 4 x's in the denominator. And since I cancel 3 x's from the top, I'm going to cancel 3 x's from the bottom, so I'm left with 1 x in the bottom. And then I'm going to cancel my y's in top and bottom. And notice I still get the negative 3 over x. Okay, so either way, depending on who you are, is correct. All right, one more straight up simplifying problem. Another one with the same idea as the first problem, where I have 2 quadratics that I need to factor. The numerator here factors to 2x. Actually, I'm not sure what it factors to just yet. I just know it's 2x and x because that makes 2x squared. And then I have a minus 2 here and a plus 1 here. That should get me a minus 3x because minus 4 plus 1 is a minus 3. And then my denominator is x minus 2 and x minus 3. If I simplify this down, I have an x minus 2 in common with an x minus 2. And so the leftover fraction is 2x plus 1 over x minus 3, and then I have to make my statement x cannot be. Okay, x cannot be 3, and x cannot be 2, because that's from the original problem before canceling. All right, that is simplification in a nutshell. It is not a complicated thing. We've actually been doing this quite a bit already when we were looking at graphing these functions, or graphing them as functions. But what I want to look at now, or what we need to look at now, is simplifying given a multiplication or a division problem. So our second problem is going to be division. Now, the process is exactly the same. We still need to factor everything. So I'm going to factor the first fraction. That first fraction is 2x plus 1 and x plus 3. That should get me the 7 in the middle. The bottom, x minus 4, just stays as x minus 4. It's the only thing there. X squared minus 16 is x plus 4. And x minus 4. And on the bottom, 2 numbers whose product is 15 and sum is 8 is 5 and 3. Oh, what happened there? X plus 5, x plus 3. I'm going to make my domain restriction statement right now. X cannot be. Okay, so from this statement, X cannot be 4. X cannot be -5. And X cannot be -3. Now I'm going to go through and cancel anything from the top and bottom. Now remember, multiplication is straight across, which means anything that's in the numerators on either side is going to remain in the numerator, and anything from the denominator is going to remain in the denominator. So I can cancel anything from the top and anything from the bottom. So here I have x minus 4 and an x minus 4. I have an x plus 3 in the bottom and an x plus 3 in the top. And that looks like the last that I can cancel. So I'm going to write my final statement here. My numerator is 2x plus 1 times, because multiplication straight across, right? This becomes x plus 4. All over, just a leftover x plus 5. And I'm actually, for the most part, okay with just leaving it like that. There's not necessarily a need to FOIL and get a quadratic in the numerator. All right, we're going to get one more example in here, and then we are going to call it. This one is a division problem. As you recall, dividing two fractions means to flip and multiply. If I was to do a small example here, 1/2 divided by 2/3 is equal to 1/2 times 3/2. I keep the first fraction and I flip the second, or take the reciprocal of the second. And again, multiply straight across, I get 3/4, but we know that. All right, so we need to factor. I'm going to leave 4 minus x alone for right now. We'll talk about that in a minute. The denominator for that first fraction becomes a 3x and something, and an x and a something, which is a -2 and a +2. And remember, factoring just comes from practice. The more you practice, the better you get at it. Right now, we're going to leave this as division. In the numerator on this side, I can factor out a 5, and that becomes x minus 4. The denominator for this one is a little bit more challenging, but it's not impossible. We have a 7x and an x. And it is a 5 and 2, I believe. So if I 5 and 2, that makes 10. And they both have to be negative, so I can make a -19. 7 times 2 is 14, plus the 5 makes the 19. All right, so from right here, we need to make the domain restriction statement. So x cannot be. Okay, subtract 2, divide by 3. So this first one is -2/3. The second one is a +2. The next one here is when I add 5 and divide by 7. And the repeating x equals 2. So here, what we have to do is we have to change it into multiplication. So I'm going to keep the first fraction. I'm going to change this to multiplication. And I'm going to flip the second fraction. So anything in the denominator becomes the numerator, and anything in the numerator becomes the new denominator. And then what we need to do is we need to look, oh, I have a new thing in the denominator that x cannot be. So x cannot be 4, so we have to add that as a new extra restriction. And that comes from that piece right there. Now that we have multiplication, now we can cancel. I have x minus 2 and x minus 2. And then there's that funky 4 minus x and x minus 4. But what I want to show you is that 4 minus x over x minus 4 can be written as negative. If I take the negative out of this, that means that x becomes positive and the 4 becomes negative, and I still get the x minus 4, which means I can cancel, and this becomes a negative 1. Now, you could do the factoring there if you would like, or you can just know that if you have 4 minus x over x minus 4, or 2 minus x over x minus 2, this is going to cancel to a negative 1, and this one's going to cancel to a positive 1. That gets rid of everything in common from top and bottom, from numerator and denominator. So I have a negative 1. I have a 7x minus 5. Over, I have a 5 here. I like to put numbers in the front of parentheses. And a 3x plus 2. And we are done. We have that piece and we have that piece as part of our final answers. They are connected. They must both be there as part of your final answers. That is our last example. I'm going to leave you as I always do, hoping that you have learned something, and I'm going to leave you with this, and I will see you guys next class.